I'm here today to talk to you about telescopes. Let's look into it, all puns intended. Although these telescopes have been perfected for over 600 years, a lot of us still don't understand the logistics of them. So I'm here to tell you that this is a reflector telescope, which contains two mirrors, the primary and the secondary. These mirrors bounce light off of one another into an eyepiece where we can see the visible electromagnetic spectrum. Through this, we see visible light rays, and with specified mechanics, we can see ultraviolet and infrared wavelengths. This is a 14-inch Schmidt-Cassegrain telescope. This means that it employs a small, convex, parabolical mirror to a focus in the primary mirror, which allows us to see our image. Chromatic aberration does not occur in reflector telescopes, but it does occur in refractor telescopes. This is why reflector telescopes are better than refractor telescopes. When light enters the glass lens in a refractor telescope, the light will disperse due to different angle deviations of different colors coming into the light prism. In our case, we use a lens corrector near the secondary mirror. Since we don't have chromatic aberration, our image we can see a lot more clearly. This is where eyepieces come into play. Eyepieces contain magnification, and this is found by dividing the focal length, which is the distance it takes to focus, so the focal length of your objective divided by the focal length of your eyepiece. The diameter of the telescope is directly proportional to its light gathering power as a whole. Therefore, a larger diameter of a telescope will yield more light, and this will enhance the light gathering power of the telescope, which will yield a more strong image. By increasing the diameter of the telescope, we get to see images such as nebula, galaxies, and stars more clearly. As the Earth rotates, the sky also moves along with it. This is why, when we align our telescope to two stars, the telescope will follow the two stars and will move along with it, so we don't have to manually move our telescope. In order to see a celestial object, we must align our telescope to two stars in the sky. We do this by using this computer program present in our Schmidt-Cassegrain telescope. This computer program allows us to access the Messier catalog. The Messier catalog is a culmination of astronomical objects seen by the French astronomer Messier. In here, we can choose our object, and the telescope will align towards it. As our telescope moves, we must move the telescope dome around with it so that the opening of the telescope dome is in the realm of our celestial eye. We would do this. I hope you know more about telescopes than you did at the beginning of this video. This telescope and its many attributes allow us to see the amazing things in the night sky, which we will continue to study for years and years to come.